Hello ladies and gentlemen, this is another in my series of videos for Algebra 2. Today we're going to be taking up the concept of inequalities using linear programming. Okay? Now, linear programming is a method to solve complex problems. You use a system of linear inequalities and you put them together and you solve them for some values. Now, linear programming is a process of either maximizing or minimizing normally, but it could be just finding particular points, okay? And you're going to be using some inequalities to be called constraints. Those are our linear inequalities. Those are called constraints. And what we're going to do when we use those constraints, we're going to identify a feasible region in which the constraints work, and that's where the overlap of the inequalities will be. That'll be the solutions, all the possible solution area. It'll be a feasible region. And then once you take that feasible region, you can maximize it or minimize it by looking at the corners of the points. So, what are we going to start with? Let's start with some word problems here. A party planner, and I need to get my notes out here, make certain I'm working these correctly. A party planner needs to rent at least 30 chairs. Wait, you know what? I can see right away that I'm going to have C greater than or equal to 30. See? At least 30 chairs. And at least 8 tables. That means that T has to be greater than or equal to 8. Okay, you see where I'm getting those from? They're not difficult to see once you read the problem. They're also telling you the daily rates for these things are saying that $2 per chair and $8 or $6 per table, 6T, has to be less than or equal to, no more than, less than or equal to $150. Where did I get that from? Right here. He wants to spend no more than a total of $150. Given these constraints, how could we solve it? Well, the one thing I'm going to do is I'm going to say, okay, going up and down is going to be T for tables. Going left and right is going to be C for chairs. Okay? And since we need 30 going across the chairs down here, I'm going to count by fives. 5, 10, 15, 20, 25, and 30. And I'll go ahead and count by fives going up to 5, 10, 15, 20, 25, and 30. Okay? So the chairs has to be greater than or equal to 30. Well, that's going to be right over here at the 30 mark. And it's going to be a line going up like this. All right? As a matter of fact, I'm going to shade that area that it is. And that's going to be shaded in green. Okay? So we're going to shade over here everything greater than 30. Okay? Cool. Got that taken care of. Now I need to get the area for the T greater than or equal to 8. Well, T is going to be my up and down. It has to be greater than or equal to 8. Well, that's 8's this line right across here. Like that. Didn't do a real good job of that line, but I tried. Okay? And then I need to shade everything above that line because it's going to be greater than or equal to 8. So I'm going to pick blue for the tables, and it's going to be everything up in here. So you can see my overlap area, right? That's pretty obvious. Yeah, that's all possible there. But my overlap area is going to be that red area there, right? I haven't got the red in there yet. So put red in here. It's going to be in this area here, right? So it's to the right of the 30 and over 8 out in here. But I haven't really solved this other equation over here yet. I need to solve this just a little bit. So to get this to work correctly, I'm going to add the negative 2c to both sides. right? And I'm going to divide by 6. And what I'm going to wind up with is that t is less than or equal to negative 1/3 c plus 25. That tells me that there's a point right here at 25 that we're going with. And for every unit down, I'm going to go over 3. 1, 2, 3. Down over 3. 1, 2, 3. I know these are in fives, but it still works. If I multiplied 5 times 5 times 3, I'd get 15. So I'm going down 5 and over 15. 3. And there's where my line would be. So I'm going to draw that one in with a solid line so that I can see where that line is. And of course, I go off the edge of my mouse pad. Let's try again. Going to go like that. Okay. And what do we get? We get a little triangular area here in which our solution is going to be in that triangular area. Okay? Pick a good color to use here. Oh, Miss Prissy likes pink, so I'll pick pink. And it'll go from this point right here to this point down here. Okay? And you can see my pink in here. That pink area is what is going to be included in the possible things. So we've graphed it out there. So they're now also asking us to find one, that's my feasible area there, okay? And that feasible area represents the area of that we could say I could select and get less than $150 in cost and get at least 30 chairs and at least 8 tables. Okay? So this point right here, we know that point. That one is at 30, 8. We know this. We can find this point over here if we wanted to. Why? Well, we know it's the y value is 8, right? And we know that it has to work in this equation up here. So 8 is less than or equal to negative 1/3 chairs plus 25. So I subtract the 25 from both sides, and I get 8 minus 25 is negative 17. 8 minus 25 is negative 17. And I divide that by negative 1/3, or multiply it times negative 3, and I get 51. So that means this point out here must be at 51, 8. Okay? And we could find this point right up here too, because we know it's at 30 chairs, right? So it's at 30 something. So I stick 30 in for C and I get negative 10 plus, that's 15 tables. So that's my 3 combinations of points that we could have. We could either get 30 tables and 8, or 30 chairs and 8 tables. We could get 51 chairs and 8 tables, or we could get 30 chairs and 15 tables, or some values that could be in between here that are inside of this pink area in here. That's what we mean by feasible area. Let's look at a couple more problems. I won't spend as much detail on them, but I do want to make certain we understand them. Okay? For a school carnival to operate smoothly and make a profit, there must be at least 60 volunteers. So that means my volunteers has to be greater than or equal to 60. And 200 customers. Well, that means my customers has to be greater than or equal to 200. Also, the number of customers must be no more than 10 times the number of volunteers. So that means customers has to be less than or equal to 10 times the volunteers. That's exactly what it says, right? So I could graph these out real quickly. Let's make this one down here my customers, and this one my volunteers. Okay? Since we're dealing with big numbers here, let's do tens. 10, 20, 30, 40, 50, 60. Okay, I don't need to go any higher than that. So it's going to be greater than or equal to 60. I mean, there's going to be a line going across there. And I'm just going to quickly hash that. Everything up in there. Okay? Customers has to be greater than or equal to 200. 10, 20, 30. Am I going to have enough? 40, 50, 60, 70, 80, 90, 100. I'm not. Okay? Wipe that out and try that one again, Charles. Didn't plan my graph very well, did I? Okay. Okay, so this is customers. And we're going to go in 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay, 200 is where we need it to be. It's going to be a line like this. And we need it to have something greater than that. Okay? Now I've got this other line over here. My customers is going to be equal to 10 times the volunteers. Well, it's going to go through 0. But 0, where's 0? It's going to go through this point over here, 0. Right? Let's see here. So I need to solve it for volunteers, because volunteers is the y-axis. So V is going to be greater than or equal to 1 over 10 customers. So my slope is going to be up 1 over 10, or up 10 and over 100. Is that right? 10. Yeah. So if I go up 10, I got to go over 100. Yeah. So I'm going to go there, and I'm going to go up 1 and over to 200, and up 1 and over to 300. You know what? I'm going off the graph, aren't I? But it's still going to be a line that looks like that. Like that. Have I got to a point where I've got a common area yet? Remember, I had everything I had up here hatched. Oh dear. Marker, come on, work with me. It won't stay lit. Okay, so we had everything up here, and we've got everything out here, right? But we also have this constraint here. The volunteers has to be greater than 10 times the customer. So that's going to be the area. Well, let's just pick a point at 2020, which I know is a valid point on my graph. Going over 20 and up 20, that point right there, it's not on the line. Stick that in here. Okay, so I got 20 is greater than or equal to 1/10 times 20, that's 2, and that's true. So that means we're shading everything above the line that we're looking at right there. And so what I'm going to do is pick my green color here and shade everything above that line and be everything up in here. And I want you to see where our common area is this area. Okay, pick different color, please. Thank you. Picking pink. It's going to be everything in this area right here. There's my constraint line. There's my constraint line. It's going to be everything up in here. Is that going to work? Let's see here. you know what? This line is going to continue on for a while, so I actually don't have the area in here that is going to be a good working point, do I? No. I've only got the intersection of these two graphs. Oh, yeah. Wait a second, the green area is up here. So yeah, that's the area that would be the intersection of all three of them, is this area up here. Okay? Now obviously once we get to a point out here somewhere, this line is going to come in and cut it off a little bit. And so we'll see it starting to decrease, but it'll be shaped like that. So it'll be a shape like that somewhere. It's everything out that direction. Okay? So those are examples of just finding values, not the particular values. Finding an optimal solution is one where you're looking for one of the vertex points of where the lines will intersect. It'll be a maximum or a minimum point. And it's done a little bit differently. So you got to read the questions a little bit differently. For example, School's Poetry Club is selling at most 80 tickets to a poetry reading. So we've got regular adults plus senior adults has to be less than or equal to 80. Okay? That's what I'm getting right here. They're selling regular and adult tickets, and they can sell at most 80 tickets. We do have some pricing in here, but that really doesn't help me a whole lot. So the objective that we're trying to reach here is the fact that we've got 10 times the regular tickets plus 6 times the senior tickets needs to be maximized. Okay? So what are we looking at? Well, there's a couple more constraints that we're missing here. One of them is they can't sell 0 tickets. So the regular tickets has to be greater than 0. And the senior tickets has to be greater than 0. Really? How about greater than or equal to 0 in both those two cases? So we're going to have a line that goes straight up on both these two sides. It's not going to be any less than that. Okay? Since we're talking about 1080s here, we'll just count in tens. 10, 20, 30, 40, 50, 50, 60, 70, 80. Okay? Now I'm going to solve this one. We're going to call this one regular tickets going this way, and this one senior tickets this way. So we want to solve this one for r. So I'm just going to solve this one for the variable r. And what we'll get is that r is equal to less than or equal to negative s plus 80. Right? So that means we're going to start at the point 80 here, and for every senior ticket we sell, we can't sell a regular ticket, so it's going to be a one-to-one slope like this. It's just going to go like this. Like that. And my area is down in here, right? This is my feasible area that we could actually sell tickets. Somewhere in here. Now, because we're wanting maximum profit, it's going to be one of my vertex points. See my vertexes? 0, 80, 0, 80, or 0, 0. Those are my 3 vertex points that I've got on here. Okay? So let's look at that. If I looked at those 3 vertex points, 0, 80, 80, 0, 80, 0, and 0, 0. Those are the 3 vertex points that we had in when we looked at the graph, right? And basically what we've got is, well, they use C for senior tickets and A for adult tickets. Won't make any difference here. So what are we looking at? If I stick 0 in for C, I get 0 plus 10A. Well, that's 800. And if I stick 80 in for C, 6 times 8 is 480 plus 0 is 480. And if I stick zeros in for both of them, I get 0 plus 0 is 0. And so my maximum profit is this 800 here. which says I'm selling 80 adult tickets. That's what it means. The maximum profit is $800. Okay? And that is if we sell 80 adult tickets. Cool? Let's look at another one real quickly. A company can make up to 24 stained and 30 unstained pictures. So 24 stained, so 24 has to be, it can make up to that. So the stains is going to be less than or equal to that. And my unstained is 30, less than or equal to unstained. And there's a limit here. It says that the inspector can only inspect 40 frames. So the S plus U has to be less than 40, less than or equal to 40. So if we make this one over here the stained and this one the unstained down here, so count by fives, 5, 10, 15, 20, 25, 30, 35, 40, going up this way, 5, 10, 15, 20, 25, 30, 35, 40. Okay? Now, we know the stains has to be less than or equal to 24. So I'm going to draw a line across here that way at 24. And we know the unstains has to be less than 30, so I'm going to draw a line at 30 going up. Like that. And this one here, I can solve this one for S and get that S is less than or equal to negative U. I keep wanting to write a Y. U plus 40. That means it'll be right here at 40, but it's going to go down like this. Down 1 over 1, 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 down 1 over 1. It's going to go just like that. So where's my feasible area? My feasible area is right in here. Like that. Okay, can we identify these points? Yeah, sure. This one here is at something 24. This one down here is at something 30 something. And this one here is at 24, 30. Is that right? Wait a second. That one's not one of the ones that's in my area. This is my area. Geez, Mr. Green. Right point so far. Yeah. So looking at this, I need to identify what this point is and what this point is right here. Okay? So if I know it's 24, that means this one must be at 16. How'd I get that? Well, 16 plus 24 would be 40. And this one over here, if this one's at 30, this one must be at 10. So it's going to be one of these two vertexes, or this one over here, or this one here, that's going to be my maximum profit. My objective profit that I'm looking for here is they make $12 on stained and $8 on unstained. So we need to write these points down so that we don't lose them, and that means I'm whipping out a pen real quickly here because I don't have it written down in front of me. So my points are at 0, 24, at 16, 24, at 30, 10, and at 30, 0. Those are my 4 points that I've got. I can tell you the ones that have the 0 in them are not going to be the ones that are going to give you the maximum profit, because obviously if we just go over a little bit to the right or up a little bit on either one of them, they're going to give us more profit. So we want to probably not check those. The ones we want to check are the ones that is the 16, 24 and the 30, comma 10. Those are the two we had, right? Let's see here. Yep, stains right. Okay? So if we use this formula here, let's see here, 12 times 16, that is 160, and 32 is 192, plus 8 times 24. Went beyond my ability to calculate it in my head, sorry. 8 times 24 is 192. Okay? 12 times 16 is 192. So we add 192 plus 192, and we get a profit of $384. Okay? Let's try the other one. 30 times 12 plus 8 times 10 gives me a total of $440. So I'm thinking this would be the one that would be the most profitable. The maximum profit is to make 30 unstained. Oh, wait a second. Got them backwards. Sorry. My screens and I don't agree on the order in which we're supposed to write these, so I've got them backwards. Let me try it again here, okay? How did I know I had them backwards? Because I had 30 stained, and we can't do 30 stained. For the stained ones here, we've got 24 stained. So 24 times 12 is 288, plus 8 times 16 is 64, is 128. Okay, I'm going to work that out on my calculator. So don't, hang on a second. 12 times 24 plus 8 times 16 gives me a total of $416. Okay, try this other one. 12 times 10, nope, 12 times 30 plus 10 times 8, no, that's backwards, Charles. 12 times 10 plus 10 times 30, 10 times, what am I doing? 8 times 30, jeez. Hard day is 360. Am I doing that right? So this is my unstained, so that's going to be 8 times 30, and this is my stained, 10 times 12. Yes, that's 360. Okay, did I do this one right? 24 times, don't think I did that one right yet. Okay, see, easy to get them confused, isn't it? Okay, so the 16 is my stained, and 30 is my unstained. Let's go back and look. This is, nope, 16 unstained, 24 stained. Okay, so this is 24 stained, so what I need to be doing here, and it helps if I write them down correctly, 12 times 24 plus 8 times 16, and that is $416. Okay, so which one gives me the maximum profit? It's this one right here. 416 is more than 360. So 24, I'm sorry, yeah, 24 stained and 16 unstained is maximum profit of $416. Okay, Now what you have to recognize that's going on here is I graphed it with stained and unstained this way, and the way this is written here, stained and unstained, it's not x and y, it's y and x. So this is a right equation. It's exactly the same equation I've got over here, 12s plus 8u. It's just written backwards, okay? Because I used s instead there. And you can see it can get confusing here, but by graphing it this way, I found the point, okay? And I just probably should have labeled it as unstained and stained so that we knew what we were doing there, okay? Cool. Now, having said that, and moving forward just a little bit here, if you're sending me questions, which I'm sure you guys will have some based upon this lesson that I just did, feel free to send them to me, and make certain that you're telling me that you are in the Algebra 2 course, because otherwise I get confused, and my finding you sometimes is paramount to answering your questions. So I will see you the next time I see you.